Example 23. A pump delivers water through 90 meters of 100 mm fire hose of friction factor 0.025 to a nozzle which throws a 25 millimeter diameter jet. The loss coefficient of the nozzle is 0.04. This is 1 over c sub v square minus 1, or simply kn, of the velocity head in the nozzle. The nozzle is 6 meters higher than the pump, and a jet velocity of 21 meters per second is required. What must be the pressure in the hose at the pump? So let's draw the figure. We're looking for the pressure at A. The nozzle is 6 meters above the pump. 100 mm diameter, the hose, and 90 meters long, and the jet is 25 mm. Remember that. So if we write energy equation between A and B, so we have velocity head at A, pressure head at A, pressure A is unknown, plus elevation head 0. Let's select diatom through A equals velocity head at the jet Vn squared over 2g plus pressure head 0 exposed to the atmosphere plus elevation head 6 plus head loss from A to N. The head loss from A to N consists only of pipe hose friction or pipe friction and the loss coefficient in the nozzle, which is 0.04 of the velocity head in the jet. Remember, the velocity head, the pressure, the head loss pipe friction is in terms of the velocity head in the hose, while while head loss in the nozzle is in terms of velocity head in the jet. So velocity head at A plus pressure head at A equals velocity head in the nozzle plus 6 plus 0.025 length 90 over 0.1 of velocity head in the pipe or hose plus 0.04 of velocity head in the nozzle. So 0.05 times 90 over 0.1 minus 1 because we have VA squared over 2G here. So PA over 9 gamma of water equals 1.04 of Vn squared over 2G because of that, plus 6 plus 21.5 velocity head at A or in the hose. So since Vn is given 21, so Vn squared over 2G is 21 squared over 19.62, and that is 22.48 meters. And Vn therefore is 21. So by continuity equation, 100 diameter of hose, 100 square velocity at A equals diameter of jet 25 square velocity in the jet 21. So V sub A is 21 over 16 meter per second. Velocity head VA square over 2G, 21 over 16 square over 19.62 is 0.0878. So substitute here, this equation, PA over 9.81 is 1.04 of 22.48 plus 6 plus 21.5 of 0.0878. So pressure at A can now be computed, 306.7 kilopascals.